So far when working with complex numbers, so numbers that have real parts and imaginary parts, so they involve I, we've looked at adding and subtracting, which we know how to do. We just collect like terms. And we also looked at multiplying, where we FOIL them, collect like terms, and don't forget that if after you multiply you end up with an I squared, you always have to replace it with -1. But today we're going to talk about what about division. So what if I'm trying to divide by a complex number? So in the first example, I have 2 plus 3i divided by 5 minus 2i. Well, the problem is this really means I have to divide by 5 and I have to divide by -2. But at the same time, we really don't know how to do that. So we're going to use a little bit of a trick. So the first thing is whenever you're working with division, you want the division to be written as a fraction or in rational form so that it's going to be easier to work with. So the question that is 2 plus 3i divided by 5 minus 2i, I'm going to write as 2 plus 3i over 5 minus 2i. And really, there's nothing I could do from there. I don't know how to divide by both of these at the same time. So we're going to use a trick. It's kind of like when we did completing the square and we used a funky zero. We added in a zero because it changed how our equation looked and let us do some work, but it didn't change the value. In this case, I'm going to multiply by something, but I'm not allowed to multiply by anything that will change this. And the only number you can multiply and not change something, multiply by and not change something, is 1. So I'm going to multiply by 1, but I'm going to make a very, very funky one. I'm going to look at the bottom, and the bottom is 5 subtract 2i. That's what I'm trying to divide by. So I'm going to make a 1 that's made out of the conjugate pair of this. So I'm going to have 5 plus 2i. We talked about yesterday what the conjugate pair was. And because I want this to be 1, I have to do 5 plus 2i on the top and the bottom. So you always look at what you're dividing by or the bottom and make up 1 based on the conjugate pair. These have to be the same. It's plus in both of them. And now I'm going to FOIL. I'm going to FOIL the top. So I'm going to do 2 times 5, which is 10. 2 times 2i, which is 4i, 3i times 5, which is 15i, and 3i times 2i, which is 6i squared. I'm going to FOIL the bottom. 5 times 5 is 25. 5 times 2i is positive 10i. Negative 2i times 5 is negative 10i. And then negative 2i times positive 2i is negative 4i squared. So we looked at this a little bit yesterday. We just didn't have such big things on top and bottom. Now, on the bottom, my i's will cancel out. And don't forget that because I squared is -1, this really becomes -4 times -1. And another way of thinking about that is plus 4. So my bottom is going to be 25 plus 4 to give me 29. The top I'm going to clean up. And again, I have another I squared here. So this is like 6 times -1. It was positive, so positive 6 times -1. So I'm really going to think about that as -6. So I have 10 subtract 6, which is 4. 4i plus 15i is 29i. Now, we haven't really done anything to get a final answer, but I could write this as a complex number. I'm going to leave it like this. It's in lowest terms. The real part is 4 divided by 29. The imaginary part, to make it complex, is 29 divided by 29, or 1i. But I could do that. I could go 4 divided by 29, write the decimal, plus 29 over 29i. And there's my complex number. But again, we'll leave it like that. We'll do some more examples just to practice. But the whole idea is you make your funky one and multiply by that. So question 2 is going to be 2 divided by 1 minus I. I don't care what's on top ever. I'm always going to multiply by a fraction. I'm going to make the fraction equal 1 by looking at the conjugate of the bottom. So because the bottom is 1 minus I, or I'm doing 2 divided by 1 minus I, my 1 becomes 1 plus I over 1 plus I. This isn't too big of a FOIL on top because I just have 2. So I end up with 2 plus 2i over 1 plus I minus I squared. Multiply the top, multiply the bottom. So the top is going to stay 2 plus 2i. On the bottom, my i's cancel out. Negative I squared is negative 1 times negative 1, or positive 1. 1 plus 1 is 2. This division works. 2 divided by 2 is 1, plus 2 divided by 2 is 1i. So it's all about multiplying by a funky 1. One more example, 3 plus I divided by I. So I'm always going to multiply by the conjugate of the bottom. Now this looks kind of weird because it's just an I, but I really want you to think about this as 0 plus I. So therefore the conjugate will be 0 minus I, and really the only important part of that is the negative I. So I'm going to FOIL the top, negative 3I minus I squared over negative I squared. I did 0 times 0, 0 times negative I times 0, I times negative I. So the top, I'm going to move the negative 3i to the second part. Negative I squared is negative 1, which is positive 1. And because this is the real number, I'm going to move it to the front. And on the bottom, I'm going to have 1 as well. So because I'm dividing by 1, I really don't need it. So my answer is 1 minus 3i. So always look at the bottom. Take the conjugate of the bottom over top of itself, FOIL the top, clean up, FOIL the bottom, clean up, and you're never going to get a nice tidy answer, but you will get complex answers. So we're taking something that isn't complex or has too many parts, and we're turning it into an answer that makes sense. Maybe not in the real world, but at least in the imaginary world, it does. So what I would like you to do is on page 363, do question number 3. It says write your answers in the form a plus bi. That's just another way of saying do the division, and then your answer should look like a complex number when you're done.